function. So let's define f of x. Let's say that f of x is going to be x minus 1 over x minus 1. And you might say, hey, Sal, look, I have the same thing in the numerator and the denominator. If I have something divided by itself, that would just be equal to 1. Can't I just simplify this to f of x equals 1? And I would say, well, you're almost true. The difference between f of x equals 1 and this thing right over here is that this thing can never this thing is undefined when x is equal to 1. Because if you set, let me define it right, let me write it over here. If you have f of, sorry, not f of 0. If you have f of 1, what happens? In the numerator, you get 1 minus 1, which is, let me just write it down. In the numerator, you get 0. And in the denominator, you get 1 minus 1, which is also 0. And so anything divided by 0, including 0 divided by 0, this is undefined. This is undefined. So you can make the simplification. You can say that this is the same thing as f of x is equal to 1, but you would have to add the constraint that x cannot be equal to 1. Now this and this are equivalent. Both of these are going to be equal to 1 for all other x's other than 1, but at x equals 1, it becomes undefined. This is undefined, and this one's undefined. So how would I graph this function? So let me graph it. So that is my y is equal to f of x axis. Y is equal to f of x axis. And then this over here is my x axis. X axis. And then let's say that this is the point x is equal to 1. This over here would be x is equal to negative 1. This is y is equal to 1 right up there. I could do negative 1, but that won't matter much relative to this function right over here. And let me graph it. So it's essentially for any x other than 1, f of x is going to be equal to 1. So it's going to look like this. It's going to look like this. Except at 1. At 1, f of x is undefined. So I'm going to put a little bit of a gap right over here. The circle to signify